Hi folks, what we're going to look at over a couple of video lessons is the idea of solving a system of three linear equations in three unknowns. Okay, now in fact the methods that we're going to develop for three equations and three unknowns can also be used for four equations and four unknowns, five equations and five unknowns, and so on and so forth. Okay, and in order to do this, we're going to do what we normally do, is we try to look at a simpler version of the problem which we already know how to solve. Okay, and that would be, of course, solving two equations in two unknowns. So as you would have seen earlier on, in order to solve for two unknowns, you need two equations. Okay, similarly, in order to solve for three unknowns, you need three equations. But what I want to focus on now is the procedures that we use to accomplish this. So, of course, one way to solve this system, and this would be a good candidate for it, would be substitution. So one way is to find a variable that's easy to isolate that variable, and then input that expression into the other equation. Okay, the one we're going to focus on here, which is going to be much more useful when solving three equations and three unknowns, will be elimination. Okay, so the idea that we perform operations on these equations to create a new equation that we can solve more easily. Okay, so I want to bring in this idea now of what are called the elementary operations on systems of equations. Okay, and a couple of them, you certainly would have used many times, and another one might seem a little odd, but it will come into play later on. Okay, so what we call the elementary operations on a system of equations, okay, are the following. So the first thing we can do is we can interchange equations. This is the one I said might seem a little odd. So here, if I were to instead make equation 1, 4x plus y equals negative 5, and equation 2, 2x plus 3y equals 15, I think it's pretty clear that the solution to the system will not change just by interchanging those equations. Not something we really do when we're working with two equations and two unknowns. But we'll see that this one will actually become useful later on. Okay, now let's get to the ones that we do use very often. Okay, so one thing you can do, and when we talk about these elementary operations, what we mean is what can we do to these equations that will not change the values of x and y that solve both equations. Okay, so another thing we can do is we can take an equation and multiply both sides by a non-zero constant. So if I take equation 1 and multiply it by 2, okay, I'll get a new equation that's equivalent, and that won't change the answer to the system if I use that new equation instead of the original one. So if I use 4x plus 6y equals 30 to solve instead of 2x plus 3y equals 15, it does not affect the solution to the system. Okay. Similarly, another thing that we can do is to add or subtract two equations to create a new equation. So especially in elimination, we know that we're going to first multiply. As you can see, we can multiply the first equation by 2, and then we'll subtract the two equations to get a new equation we'll use to find a solution. And again, that operation will not change the values of x and y that solve the system. Okay, so these are our three elementary operations, and any combination of these operations will not change the values of the unknowns. Okay, so this is what we have to work with. So let's actually perform the operations necessary to solve this system of equations. Okay, and then we'll see how we can upgrade these procedures to work for system of three equations. Okay, so here, this is something you've done many, many times. So I can either multiply the first equation by 2 or choose to multiply the second equation by 3. Either one is okay, and either one will lead us to the answer. So I'll choose to multiply equation 1 by 2. So my new equation that I will use will be 4x plus 6y equals 30. Okay, so this now replaces equation 1, and I'll leave equation 2 as it is. 4x plus y equals negative 5. So even though I'm working with a new equation, it does not change the solution to the system. So here now, I'll use that elementary operation number 3. I'll subtract these two equations to get a new equation altogether. So 4x minus 4x, 0, 6 y minus y is 5y, and then here 30 minus negative 5 is 35. Okay, so I've now created a new equation. However, this value of y will be the same as the value of y which solves the original equation. That's what makes it an elementary operation. So here we can find that y is equal to 7. Okay, and then we can go back and reuse one of these equations to solve for x. Okay, so here I'll use equation 1, so 2x plus, and again this value of y from my new equation is also the same as the one in equation 1, so I can now input for the value of y, the value 7 equals 15, and now solve. So here we have 15 minus 21 is negative 6, and so x is equal to negative 3. And so the solution to this system of equations is x equals negative 3 and y equals 7. And the fact that I worked with equations that were not the original ones, as long as they are elementary operations that have been performed, the answers will work for both the new equations I created and the original ones. Okay, so what we'll see in the next lesson is how we can use these elementary operations to solve a system of 3 equations and 3 unknowns.